All right, so today we're really diving deep, and it's thanks to you, our
Mhm.
listeners. You sent over a case study
Yeah.
from Cognitive Market Research, and it's a fascinating one. It's all about this heavy manufacturing company,
Mm.
and they basically decided they had enough with their equipment constantly breaking down,
Yeah.
right? It was costing them money, it was costing
Mhm.
them time.
Of course.
It was just a mess. So we're going to really dig into how they kind of pulled themselves out of this
Mm.
cycle of constant repairs, constant breakdowns,
Yeah.
that reactive mode. They really wanted to move towards something more sustainable
Right.
and effective.
Yeah, this is a story that's going to resonate with a lot of folks out there in the manufacturing world. I mean, just picture it, production line suddenly screeches to a halt.
Oh, yeah.
Teams of people are scrambling to figure out what went wrong. The
Yeah.
costs are just piling up. In this company, they were right in the thick of it.
Mhm.
Their old way of doing things, sort of that traditional maintenance.
Yeah.
You either wait for something to break and then fix it,
Right.
or you're just kind of going by the calendar.
Right, just routine checkups.
Yeah, routine checkups, it just wasn't working for them. It either meant they were doing way too much maintenance, spending time and money on things that didn't really need it, or even worse, they were missing those early warning signs.
Right.
Those little red flags that something is about to go haywire,
Exactly.
and then bam,
Mhm.
huge breakdown, massive
Right.
costs.
Yeah, and the study even gets into how this wasn't just an internal problem.
Oh, absolutely.
It really rippled out. It messed with their supply chains,
Yeah,
their ability to deliver on time,
sure.
meet their commitments.
For sure.
So it really became a kind of a strategic problem, not just a maintenance problem.
Absolutely. So the million-dollar question is, how did they break free from this? What was the big aha moment for them?
Yeah, what did they do?
Well, they made a pretty bold decision. They decided to harness the power of, the buzzwords everybody's talking about,
I know where you're going.
artificial intelligence and machine learning.
Mm-hmm. Yeah.
That's right. Their goal was to create what they called a data-driven, condition-based predictive model.
Okay, break that down a little bit for me. What does that actually mean in practice?
So it's about moving away from just reacting to problems as they pop up.
Okay, yeah.
They wanted to be able to predict, anticipate when a piece of equipment might be on the verge of failing,
Mm-hmm.
and then step in and do something about it before it turns into a major catastrophe.
So it's almost like giving their machines a voice so they can
That's
tell them, hey, I'm not feeling so good before they completely collapse.
You got it. That's a great analogy.
Okay, so they're aiming for this predictive approach, but what were they actually hoping to achieve? What were the concrete benefits they were looking for?
Well, they were hoping for a whole bunch of improvements.
Yeah.
First and foremost, improved reliability.
Okay, so fewer breakdowns.
Fewer unexpected shutdowns. Yeah,
Keep those production lines humming.
exactly. Keep things running smoothly. And naturally, they wanted to see a nice, hefty reduction in their maintenance costs.
Makes sense, yeah.
By optimizing their maintenance efforts, they could avoid those super expensive emergency repairs.
Right, because those can really add up.
Oh, yeah, big time. And they were also looking at the long game, aiming to extend the lifespan of their equipment.
Right, get more bang for their buck.
Exactly, make those investments last longer. And all of this, of course, feeds into the bigger goal of achieving better overall efficiency
Yeah.
across their entire manufacturing operation.
All right, so let's go back to the beginning, right?
Sure.
The old way wasn't working. They were doing too much unnecessary maintenance or not enough, and it was leading to these breakdowns. Can you kind of unpack that a little bit? Why does that traditional preventive maintenance approach, why does it often fall short in a complex setting like a heavy manufacturing plant?
Well, traditional preventive maintenance, it often relies on these fixed schedules, right?
Right, okay.
It's like changing the oil in your car every 6 months.
Right, or every so many miles.
Yeah, exactly. Every so many miles, regardless of whether you've actually driven that much.
Whether you've been doing, short trips.
Yeah, short trips or long hauls,
Mhm.
doesn't matter.
Yeah.
And in a big factory, this can mean you end up servicing equipment that's actually in tip-top shape,
Right, just wasting time and money.
wasting resources, yeah. Or, on the flip side, you might miss those subtle signs of wear and tear on components that are under a lot of stress.
Right, because they're being used more heavily.
Exactly, they're working overtime.
Yeah.
And so even though you're doing those routine checkups, you might still get those sudden disruptive failures.
Hmm. And then, of course, when something does break down unexpectedly, you've got the repair costs.
Yeah.
But then you've also got all the downtime, the production losses,
Right.
and potentially even, disruptions to your supply chain.
Absolutely, it can snowball pretty quickly.
Yeah, so they realized, okay, This calendar-based approach, it has its limitations.
Yeah.
And they decided to go all in on this data-driven, condition-based predictive model. So it sounds like it's a pretty big shift in mindset.
It was a complete overhaul of their approach.
Yeah.
I mean, instead of relying on guesswork or fixed schedules, they were moving towards a system that's constantly monitoring the actual health of their equipment.
Okay.
Listening to what the machines are telling them, and then using that information to predict when maintenance will be needed.
Right.
And this was all made possible by, bringing together several key elements, what they call real-time analytics,
Okay.
IoT-enabled sensors, and
IoT, the Internet of Things.
exactly, the Internet of Things, and of course, those powerful machine learning algorithms.
So they were essentially giving their machines a way to speak up
Yes.
and then creating a system that could understand that language and anticipate problems.
Exactly. So the first step was to start gathering all that valuable data.
Right.
The study really emphasizes how important data collection was.
So how did they go about setting up this whole system to capture the information they needed?
Well, they basically blanketed their entire operation with these little devices called IoT sensors.
Okay.
And, they put them everywhere.
Like what kind of equipment are we talking about specifically?
Oh, you name it, they had it.
Mm.
Production lines, motors, pumps, hydraulic systems, even the conveyor belts,
Wow.
all outfitted with these sensors. And these things are pretty clever. They can measure all sorts of parameters in real time. So they were collecting data on things like vibration levels.
Okay, so is a machine shaking more than it should?
Exactly. Temperature is running hotter than normal. Pressure, energy consumption patterns. Is a motor suddenly drawing a lot more power than usual?
Right, like it's working harder.
Yeah, like it's struggling.
Yeah.
And even, get this, even the viscosity of fluids, like lubricants.
Wow, so they were really capturing a holistic picture of how each piece of equipment was performing.
That's the idea, a complete picture of the machine's health. And all of this data, all this valuable information, it wasn't just, disappearing into the ether.
Right, it had to go somewhere.
It was all channeled to a centralized cloud-based platform.
Okay, so everything was going up to the cloud.
Up to the cloud.
Where it could be accessed and analyzed.
Exactly. It's like having a central nervous system for the entire operation.
So they had this constant stream of real-time data coming in, but the study also mentions that they incorporated historical data as well.
Yeah, that was a crucial piece of the puzzle. They integrated their historical maintenance records.
Okay, so records of past failures.
Right. Past failures, repairs, routine maintenance, all that valuable historical information.
So why was that so important?
Well, because it gives the AI context.
Yeah.
Right? It's like giving the system a memory.
Uh-huh.
So it can start to see patterns, connect the dots between what happened in the past
Right.
and what's happening in the present.
So we can learn from experience. Is that
Exactly. Learn from experience. The AI can look back at what happened before a particular type of failure
Yeah.
and then recognize if similar patterns are starting to emerge in the live data.
Okay, that makes sense. So they're collecting all this data, both
Mhm.
real-time and historical, but how do they actually make sense of it all?
That's where the machine learning models come in. This is the brains of the operation.
Right, they've got to have some way to analyze and interpret all this information.
Exactly. And they use both supervised and unsupervised learning techniques.
Okay, two different approaches to machine learning. Can you explain the difference?
Sure. So supervised learning is kind of like teaching the AI with flashcards.
Okay.
You show it labeled examples.
Mm.
In this case, they fed the AI historical data where they knew a failure had occurred, along with the sensor readings leading up to that failure.
Okay.
So the AI learns to associate those specific patterns in the data with an impending breakdown.
So if it sees those patterns again,
Right.
it can say, hey, this looks familiar, this might be a problem.
Exactly. It's like, uh-oh, I've seen this movie before and I know how it ends.
Right, right. Okay, so that's supervised learning. But you mentioned unsupervised learning as well. What's that all about?
Unsupervised learning is really fascinating because it's more about letting the AI explore the data on its own
Okay.
and identify anomalies, unusual patterns, without being told what to look for.
So it's like saying, here's a mountain of data, go find something interesting.
Yeah, exactly. It's like, go see what you can discover.
Okay.
And the AI might find machines whose data patterns deviate significantly from the norm,
Right.
even if those deviations don't match any known past failures.
So it's kind of like a detective looking for clues
Yeah.
that might not fit the usual profile.
It's like the AI is saying, hey, this looks different. This might be something new, something we haven't seen before.
So it's a way to uncover potential problems
Yeah.
that might not fit the existing patterns.
Exactly. It's a way to stay ahead of the curve.
Okay, I'm starting to see how these two approaches work together. Supervised learning helps predict those known issues,
Right.
while unsupervised learning is kind of like an early warning system for the unexpected.
That's a great way to put it.
And it sounds like these AI models, they weren't just static, they were constantly evolving.
Oh, yeah, absolutely.
Yeah.
They were constantly learning and adapting. As the system collects more data
Mm-hmm.
and as maintenance actions are performed, that new information is fed back into the models.
Right, so it's a continuous feedback loop.
A continuous learning cycle.
So the AI is constantly being refined,
Yeah.
getting smarter, making better predictions over time.
And the study even mentions they were using some pretty advanced stuff like convolutional neural networks, CNNs,
Right.
and recurrent neural networks,
Mhm.
RNNs.
Okay, those are some big, complicated terms. Can you give us a simple explanation of what those are all about?
Well, they're basically types of AI algorithms that are really good at finding complex patterns in massive data sets.
Okay.
Like, think about how your brain recognizes images or understands sequences of words.
Yeah.
These deep learning techniques can do similar things with data.
So they're like pattern recognition on steroids.
That's a good way to put it. They can find hidden correlations that a human analyst might miss.
Wow, that's pretty powerful. So the AI is constantly on the lookout, learning from every bit of data,
Yes.
every maintenance intervention, to get better at predicting future issues. But when it does spot something that looks out of the ordinary, what happens next? The study talks about real-time predictions and alerts.
That's right. So when the system detects an anomaly, something that suggests a potential problem, it immediately generates alerts.
Okay, so it's not just passively collecting data, it's actively looking for trouble.
It's like a watchdog, constantly on guard.
So what form do these alerts take?
Well, they can be sent out in various ways. They might pop up on a dashboard in the maintenance office,
Okay.
so the team can see it right away. Or they might get sent as email notifications,
Mm-hmm.
or even pushed directly to the mobile devices of the technicians out in the plant.
So no matter where they are, they're getting that heads up.
Exactly. The key is that this enables a proactive approach.
Right, they're not waiting for something to break down.
Yeah.
They're getting an early warning.
Yeah.
So they can investigate and address the issue before it becomes a major headache.
Exactly. They can get ahead of the problem. It's like getting a health alert for your machinery,
I like that.
giving you time to schedule a checkup before things get critical.
Okay, so the AI is raising the flag,
Mm-hmm.
but the study also talks about automated workflow. So it sounds like the AI is doing more than just saying, hey, there's a problem.
That's right. It's not just about sounding the alarm. It's also about helping to solve the problem.
So what does that involve?
Well, they integrated the predictive maintenance system with their existing ERP.
ERP, Enterprise Resource Planning.
Exactly, Enterprise Resource Planning. And their CMMS,
Okay, what's a CMMS?
a computerized maintenance management system.
Okay.
So all their systems are talking to each other.
All right, so everything's connected. And what does that integration actually allow them to do?
Well, it means the AI can not only predict failures, but it can also recommend specific actions.
So it's not just saying, heads up, something's wrong.
Right.
It's saying, here's what you should do about it.
Exactly. Based on the predicted issue, the system might suggest, hey, it's time to replace this particular component.
Okay.
And it might even trigger the ordering of the necessary parts automatically.
Wow, that's streamlining things.
Streamlining, yeah. And can even schedule the right maintenance personnel to do the work.
Right, so it's taking care of the logistics as well.
It's taking care of everything. It's like having a super efficient maintenance assistant
Yeah.
that's working 24/7.
So the study talks about a shift from rigid time-based maintenance schedules to dynamic condition-based plans. Can you explain what that means and why it's so important?
Sure. So instead of sticking to a fixed calendar, servicing a machine every 3 months, no matter what,
Right.
they're now performing maintenance based on the actual condition of the equipment,
Okay.
as indicated by the real-time data.
So it's a much more targeted approach.
Targeted and efficient,
Hmm.
they're not wasting time and resources on machines that are running perfectly fine.
And that probably saves them a lot of money as well.
Oh, absolutely. It's a huge cost saver.
So we've got the AI making predictions, triggering alerts, recommending actions, even handling some of the logistics. But the study also emphasizes this idea of continuous model improvement and a feedback loop.
Yeah, this is really important. This system, it wasn't just set up and then left to run on its own.
Right.
It was constantly being refined and improved.
So how did that work in practice?
Well, the maintenance personnel, the people actually out there working on the machines, they were providing feedback on the AI's predictions.
Okay, so they were part of the process.
A crucial part of the process. They would say, hey, this alert was spot on. We caught the problem just in time.
Right.
Or maybe, this recommendation wasn't quite right. We needed to do something slightly different.
So that real-world experience was being fed back into the system.
Exactly. And that feedback was used to tweak the algorithms, refine the models, make them more accurate and effective.
So it's a learning process, not just for the AI, but for the humans as well.
Yeah, it's a collaboration. Everyone's learning and improving together.
Okay, so it all sounds great in theory, but how do we know it actually worked?
That's a great question. And the study talks about the importance of data validation.
Okay, so they wanted to make sure they were actually getting results.
Exactly. They didn't just want to see correlations. They wanted to prove causation.
Right, show that the AI was actually making a difference.
And they did that by rigorously comparing the AI's predictions with their historical failure records,
Okay.
analyzing how often it correctly predicted failures, how often it issued false alarms,
Right.
and they used that information to fine-tune the models, improve their accuracy.
So they were really putting it to the test, and they didn't just roll this out across the entire operation right away, did they?
No, they were smart about it. They started with a pilot phase.
Okay, so they tested it out on a smaller scale first.
Yeah, they implemented it on a subset of their equipment to see how it performed in a real-world setting.
And how long did this pilot phase last?
About 6 months.
Okay, and what were they looking at during that time?
Well, they were tracking a few key metrics, things like mean time between failures, MTBF.
Okay, so how often equipment breaks down?
Exactly, mean time to repair, NTTR.
How long it takes to fix it?
Right, and of course those all-important cost savings.
And what did the results of the pilot show?
Well, the results were very encouraging. They saw significant improvements in all those areas,
Okay.
which gave them the confidence to move forward with a full-scale implementation.
So they weren't just looking at the numbers either.
Yeah,
Right.
right.
The study also mentions that they gathered operational feedback from the maintenance teams.
Oh yeah, that was crucial. They wanted to make sure the system was actually user-friendly,
Okay, yeah.
that the alerts and recommendations were easy for the engineers and technicians to understand and act on.
Right, because if it's too complicated, if people can't use it easily,
Exactly.
it's not going to be very effective.
And not effective at all. So they were actively seeking input from the people on the front lines to make sure the system was practical and useful.
So after all this careful planning and testing, what were the actual outcomes? The client achievements section of the study sounds pretty impressive.
Yeah, they achieved some really remarkable results.
Like, give us some specifics. What kind of improvements did they actually see?
Well, first of all, they achieved a 50% reduction in unplanned downtime.
Wow, that's huge.
That's massive.
Yeah.
Think about what that means. They cut in half the amount of time their production lines were unexpectedly out of service.
So that means more products,
More products,
fewer delays,
fewer delays,
happier customers.
happier customers. Exactly. It's a win-win all around.
Yeah, and it sounds like it had a significant impact on their bottom line as well. The study mentions a 25% cost savings in maintenance operations.
Right. So they were saving a ton of money. And these savings came from a few different areas.
Like what?
Well, optimizing their maintenance schedules meant they weren't doing unnecessary work.
Right.
They were avoiding those really expensive emergency repairs.
Yeah. Which often involve, rushing parts and
Yeah. Rush orders, overtime, it all adds up.
fewer breakdowns overall.
Fewer breakdowns overall, that's the key.
And the benefits went beyond just the immediate cost savings, didn't they?
They did. The study also talks about extended equipment lifespan and sustainability gains.
So it sounds like this wasn't just about fixing things faster.
Yeah.
It was about making things last longer
It's about being proactive, yeah.
and being more environmentally responsible as well.
Absolutely. By catching those early signs of wear and tear, they were able to prevent minor issues from escalating,
Right.
which meant their equipment lasted longer.
Okay.
They didn't have to replace things as often, which reduces waste
Right.
and is better for the environment.
So less downtime, lower costs, longer equipment lifespan, and even environmental benefits.
It's a pretty compelling case study.
It is.
It really shows how transformative these AI-driven maintenance strategies can be.
So for you, our listeners, I think the key takeaway here is that by combining sensors, data analytics, and AI, companies can really revolutionize how they approach maintenance.
Absolutely. It's not just about fixing things when they break.
Right.
It's about predicting and preventing those breakdowns in the first place, which leads to all sorts of benefits, like we've discussed: less downtime, lower costs, and even more sustainable practices.
So it's a win for the company, it's a win for the environment,
For sure.
and ultimately it's a win for the customer as well.
Absolutely. Everybody benefits.
Okay, so we've seen how powerful this approach can be in the world of heavy manufacturing. But as we wrap up, I want to leave you with a thought. What other industries or complex systems could potentially benefit from this kind of proactive, data-driven approach?
That's a great question to ponder.
Think about it, right? Transportation networks, energy grids, healthcare systems. Could we use this kind of predictive power to anticipate problems in those areas as well?
It's definitely something to think about. I mean, imagine if we could predict traffic jams
Right.
or power outages
Yeah.
or even medical emergencies before they happen.
It could really change the game.
It could revolutionize how we manage these complex systems.
So that's something for you to consider, to explore further. The possibilities are really quite exciting.
Absolutely.
And that's it for our deep dive today. Thanks for listening.
Thanks for having me.